An angle is in standard position if you have the vertex placed at the origin. Now the vertex of an angle is the corner. It's where the two rays that form the angle meet. So right here is the origin where this O is, and I just put a blue dot. And you have two sides. One is called the initial side. That's where the angle starts. The initial side is always going to be along the positive x-axis. So the initial side of the angle is always going to be this right here. And then you have the other ray, so the other side of the angle is called the terminal side, and that's where the angle stops. So the terminal side would be this side right here. So for an angle to be in standard position, you have to have the vertex at the origin. The side where it starts has to be on the positive x-axis, so on the right side of the x-axis. And then the terminal side can be wherever, and that's what a lot of what we're going to talk about today is how to figure out where that terminal side is. The other thing we need to talk about is that you can have an angle that either has a positive measurement or a negative measurement. In order to know the difference, you think about clockwise and counterclockwise. So in order for an angle to be measured in a positive direction, it means that the terminal side is rotating counterclockwise. So right here it says draw a 60-degree angle. So that means that my initial side, my vertex is at the origin, initial side is going to be on the positive x-axis, and then the terminal side is going to be 60 degrees rotated counterclockwise. So that would be going in this direction. And this is 0 degrees. This would be 90 degrees up here. So 60 degrees would be something like right here. So that would be a 60-degree angle. If I were to talk about a negative 60-degree angle, it would be the exact same measurement, but now I'd be rotating clockwise. So my vertex would still be at 0, 0. My initial side would still be at the positive x-axis, but now I would measure going clockwise 60 degrees. So this would now be my angle, measured negative. In order to draw an angle in standard form, the first step we're going to do is to label all the quadrantal angles. And this is something that you will hopefully have memorized eventually if you don't already. So I'm starting here at 0 degrees, and then I'm going to add 90 every time that I rotate to the next axis. So 90, this would be 180 degrees, 270, and then one full rotation is back where we started, so it's 360 degrees all the way around. The next thing we're going to do is identify which two of the axes the angle is in between. So in our problem, we're trying to figure out where should we draw 120 degrees. Well, 120 degrees is in between 90 and 180 degrees. The next thing we need to do is figure out when we draw the terminal side of this angle, should it be a little closer to 90, should it be a little closer to 180, or is it exactly in the middle? So the way I like to do it is just to figure out how far away from 120 is 90 degrees and how far away is 180. So if I did 120 minus 90, it would tell me that I need 30 more degrees to be added onto 90 to make it 120. And then if I did 180 minus 120, it would tell me that it's 60 degrees away. So because 90 is only 30 degrees away, that means it's actually closer. So when I draw the terminal side of this angle, I'm going to draw it a little bit closer to the 90-degree angle than from the 180 degree. The last thing I have to do is to draw an arrow indicating which way the angle rotated. So because this is a positive angle, it's going to be rotating counterclockwise. So I'm going to draw my arrow, and then I'm just going to put 120 degrees here to label that that's the measure of this angle. For example 2, we're going to do almost the exact same thing. I'm going to start out the same way. I'm going to put my quadrantal angles onto my graph. But what you'll notice is that 480 is not in between any of the angles that I have written up there right now. It's too big. So what that means is that the angle 480 is more than one full rotation. So what I'm going to do is I'm going to continue adding 90 to 360 until I get two angles that I know 480 is in between. So if I add 90 to 360, that gives me 450. That's still not big enough though. And if I add 90 one more time, I get 540, which is now big enough. So now I can tell you that we're going to be in quadrant 2 because 480 is in between 450 and 540. Now we have to figure out where it's closer. So we're going to do the same thing where we figure out how far away it is. So if I subtract 480 minus 450, it tells me that if I added 30 degrees, that would get me to 480. And then similarly, I'm going to take 540 and subtract 480, and it tells me that it's 60 away. So again, it's closer to the 450 degree angle. So I'm going to draw it to look like this. Now you may notice that the two angles that I drew, the terminal sides, are identical. They're exactly the same amount of degrees away from the positive y-axis. And that is not a coincidence, but the difference here is that the number of rotations is not the same. So 120 degrees, we only had to rotate part of a rotation. For 480 degrees, we have to go all the way around plus the 120 degrees. So it's a full rotation plus the 120 degree angle. And there is actually a special name for angles that are like this, where they have the same terminal side but a different number of rotations. And that name is coterminal angles, which is down here. So anytime you hear something about coterminal angles, all it means is that they look the same, they have the same spot where they stop, but they rotated a different amount of times to get there. We're now going to draw an angle that's in standard position that's negative. So the only difference here is that now instead of everything going counterclockwise, everything's going to go clockwise, and we're talking about negative angles. So we're going to start here at 0, and then I'm going to go through now clockwise, and I'm going to label all of my angles, my quadrantal angles. So this would be negative 90 degrees, negative 180, negative 270, and negative 360. We're looking to see where 135 degrees falls. That would be in between negative 90 and negative 180. So now we have to figure out which one it's closer to. If I figure out what the difference is in between these two angles, and for my purposes here, I'm kind of thinking of it like an absolute value. I don't really care that they're negative. I just want to know how far apart the numbers are. So if I take 135 and I subtract 90, the answer that I get is 45. So what that means is that if I take negative 90 and I subtract 45 more degrees, that would get me to 135. Now I'm going to take 180 and I'm going to subtract 135. And again, I'm not really worried too much about the negative angles. I just want to see how far apart these numbers are. If I subtract those, I also get 45 degrees. So what that means is if I added 45 degrees to negative 180 degrees, it would also get me to 135. So since those two things are the same, I'm going to draw my terminal side exactly in the middle of quadrant 3. And then the last thing I have to do is draw that angle to show my rotation. This time, because it's a negative angle, I am going to draw my arrow going clockwise. We talked about how to convert angles from degrees to radians and radians to degrees in lesson 1. So really quickly, I just want to refresh your memory. If I want to take something that's in degrees and change it into something in radians, I'm going to multiply by pi over 180 degrees. And that's exactly what we want to do here. So I'm giving you 5 different angles that are in degrees, and I want you to tell me what their equivalent measure is in radians. So let's start with 0. That's going to be an easy one. If I take 0 degrees and I multiply by pi over 180, 0 times anything is still 0. So my answer here is 0, but now it's not 0 degrees, it's 0 radians. Now let's take 90. So now I'm going to do 90 degrees times pi over 180 degrees. So depending on how you want to do this, you can use your calculator to simplify, but either way, you should get that this is equivalent to pi over 2 radians. And it kind of makes sense when you think about it, because 90 is half of 180, so it should be, you have 1/2 and then the pi is in the numerator. All right, next we need to talk about 180 degrees. So I'm going to do 180 degrees times pi over 180 degrees. These 180s cancel each other out, and all I have left is pi. So that means that 180 degrees is equivalent to pi radians. For 270, If you simplify that, 270 over 180 reduces to the fraction 3/2. So this is going to be equivalent to 3 pi over 2 radians. And then last but not least, 360. 360 is 2 times 180. So that means this is going to simplify to 2 pi. And so what I want to do here is at the beginning of this lesson, we were labeling the quadrantal angles in degrees. So we were saying it was 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Now what I want you to see and hopefully start to memorize is what these quadrantal angles are in radians. So 0 degrees is 0 radians. That's an easy one. 90 is pi over 2 radians. 180 is pi radians. 270 is 3 pi over 2 radians, and then 360 is 2 pi radians. When we're trying to figure out where an angle should be drawn in standard position, if we're dealing in radians, what's going to be really helpful to us is to make sure that everything has a common denominator. And that'll make it easier because then we can just compare the numerators. Once the denominators are the same, then comparing fractions is not such a big deal. So we're going to follow these steps. It seems a little bit daunting at first, but once you practice it a couple times, I think you'll see that it's not as bad as it originally seemed. So step 1 is we're going to write a fraction with the common denominator at each of the quadrantal angles. And when I say common denominator, I mean the same denominator as the angle we're trying to draw. So if you look at the angle we're trying to draw, it's 5 pi over 4. So what I'm going to do is I'm going to make everything over 4. And I'm leaving all the numerators blank. We'll deal with that in a minute. Okay, so that's step 1. Not too bad. For step 2, on the first angle on the positive x-axis, it's always going to be 0 pi over 4. Okay, that one will never change. It doesn't matter what the original problem is. Whatever your denominator is, you put a 0 pi in the numerator. All right, step 3. We take half of what our denominator is, and that will be the numerator on our next angle, which is like our 90-degree angle or our pi over 2 angle. That'll be our next one. So our denominator in this problem, and I'm going to write this up here, our denominator is 4. So if I take half of our denominator, half of 4 is 2, right? So that means that my next angle is going to be 2 pi over 4. And if you think about it, I'm going to do this in green up at the top. If I take 2 pi over 4 and I simplify it, 2 over 4 is 1/2. So it is pi over 2. I'm not actually changing the number, it's just that I'm changing the denominator, so it looks different. All right, so that was step 3. Step 4 is now that I've gotten that number, that 2 that I put up at the positive y-axis, I just keep adding that number until I get all the way around. So I started with 2 pi over 4. If I add 2 plus 2, that's 4. So this is going to be 4 pi. 4 plus 2 is 6, so that's 6 pi. And then 6 plus 2 is 8, so this is 8 pi. So now I have all my quadrantal angles in radians, but now I can compare them with my 5 pi over 4 because they all have the same denominator. So now I can see 5 pi, that's all I'm really paying attention to is my numerators now. 5 pi is in between 4 pi and 6 pi, and it's exactly in the middle. So now I know this is where my angle would go. Okay, and it's rotating counterclockwise because it's positive. So really the hard part is figuring out how to get all your denominators to be the same. Once you get that part done, it's really not as bad as it looks. All right, so example 4 I basically did on the previous slide, but I'll go through it a little bit slower this time. So we went through and we changed all of our denominators to 4. So the first thing you do is you do all of your fractions at the quadrantal angles over 4, and make sure that you have 2 of them on the positive x-axis because you have 0 and you have 1 full rotation, which is 2 pi. All right, so here are my common denominators. The next thing I do is I take my denominator of my original problem and I divide it by 2. Half of 4 is 2. Oh, I'm sorry, I skipped a step. This should be 0 pi. Always 0 pi. All right, so half of my denominator is 2, so that makes this 2 pi. And then I just keep adding 2 all the way around. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. All right, now what I'm doing is I'm looking at my numerator, which is 5 pi, and I look at all the numerators that I just labeled, and I figure out where does 5 fit. Well, 5 fits in between 4 and 6, and it's exactly in between them because it's 1 away from each. So that means my angle is going to be exactly in the middle of quadrant 3, and because it's a positive angle, I'm going to be going counterclockwise. So I draw my angle, and I label it, and that's it. We're done. Let's take a look at example 5. So this time I'm drawing the angle 13 pi over 4 in standard position. So I am going to do the exact same thing. And it's actually, I mean, not only is it the exact same process, it's the exact same numbers because my denominator is still 4. So remember, your first one is always 0 pi. If I take half of the denominator, half of 4 is 2. So this would be 2 pi. And then I just keep adding 2 all the way around. So this would be 4 pi, 6 pi, and 8 pi. We have a problem here, though, because 13 is bigger than 8. So that means I still don't know where it fits. So this is like that one where we had to graph or draw the 480-degree angle. It's more than a full rotation. So I'm just going to keep adding 2. So 8 pi plus 2 pi would be 10 pi. Then this would be 12 pi, because all I'm doing is adding 2 to my numerators. This would be 14 pi. All right, so now I'm in a good spot, because now I can see 13 is between 12 and 14. And again, it's exactly halfway in between. So I'm going to put my terminal side of the angle right in the middle of quadrant 3. The only difference between example 4 and example 5 is when I draw my arrow, I have to show that it went one full rotation plus another part of a rotation. So it goes all the way around plus this part. So again, just like the 120 and 480 degree angle, they had the same terminal side. These also have the same terminal side. So that means these are also coterminal angles. So you can have coterminal angles in degrees and radians. The definition is exactly the same. It's just it's a little different when you're looking at it in terms of radians. All right, so now let's take a look at a negative angle. So again, same process as with the degrees. I'm going to label my quadrantal angles. This time I'm going to go counterclockwise though. So my denominator here is 3. So that means I'm going to do everything over 3. And I'm going to put negatives here because I'm afraid I'll forget later. So this one should also be negative. Okay, so my very first angle always going to be 0 pi over 3. Something a little strange is going to happen here. Up until now, all of our denominators have been 4. 4 divides by 2 into a whole number, no big deal. The difference here is that 3 is not divisible by 2. We're going to get a decimal, and that's okay. It's going to look a little strange, but it's okay that we're getting a decimal, because really what we're using it for is just to compare numbers. So even though it looks kind of funny, that's okay for right now. All right, so half of 3, I'm going to put that up here. If I take half of 3, that's going to give me 1 1/2, 1.5. So that means this right here, my first quadrantal angle, and remember we're going negative, so that's why I'm going the other direction, is going to be 1.5, negative 1.5 pi over 3. And now I'm just going to keep adding 1.5 until I get all the way around. So if I added 1.5 and 1.5, that would give me 3. Then I would get 4.5, and then finally 6. So now remember that I'm trying to figure out where does negative 5 pi over 3 belong. So 5 would be in between 4.5 and 6, negative 4.5 and negative 6. And 5 is only half away from 4.5, but it's a whole 1 unit or 1 radian away from 6. So I'm going to draw my terminal side a little bit closer to the negative 4.5 because it's a little bit closer to that. And then when I draw my arrow, I have to make sure that I go counterclockwise so that it's representing a negative angle in radians.